Okay, this is the calculator demonstration from Jonathan Lloyd, Patrick Grant and Edward Martin. So we have a calculator that performs 4 functions. We have an add, a subtract, a multiply and a divide. In the 7 seconds to begin with, when the board is first turned on, we have a number 1 which prompts the user to enter the first number of the sum. So we have 4 inputs set up for the buttons. We have S1 through 4 are set up as binary inputs. So of course we have 1, 2, 4 and 8, which allows the user to enter up to 15 as a 4-bit binary number. So if we do an addition first of all, and we do 2 plus 2, so we have 2, and then we're going to press the enter button, and then we load a second 2. Just to point out that the LEDs are set up to act to reflect what numbers have been put in to the calculation. So if we enter the second number, then we do another 2. That shows that the second 2 is then being put into the other register, and then the board is set up so that S4 is add, S3 is subtract, S2 is divide, and S1 is multiply. So if we select S4 to do an add, and then we press the enter button again, that will give the answer of 4 on the 7-segment displays. Okay, so if we now do a subtract operation, so if we do 6 minus 4, so we can now see 6 is now entered on the binary inputs using S3 and S2, and you can see there that the 6 has been entered into the first register. We then do 6 minus 4, so if we press the enter button again to enter the second number. Sorry, we're going to do 6 minus 2. Sorry. So then if we hit S3 then to do the subtract operation, and then hit the enter button again, you can see that 4 is coming up on the 7-segment displays as the solution to 6 minus 2. Okay, so if we now demonstrate a divide operation, so if we do 14 divided by 2, so 14 is entered on the binary inputs, the number is stored, and then 7 is selected on the binary inputs. Sorry, 2 is selected on the binary inputs, my apologies. And then we select divide using S2, then hit the enter button again, and 7 can be seen as the answer in the 7-segment display. So multiply is our final operation, so if we do 15 by 5, so 15 is entered on the binary inputs, then followed by 5 being entered into the second register, and then S1 is then used to signify a multiply operation, and again enter is used to enter the calculation, and as you can see 75 appears on the 7-segment display, which is the correct answer. Also, another feature of the board is that if we did have a third 7-segment display, it would display calculations larger than the 2 7 segments currently allow. So if we enter 10 by 10, sorry, do 15 by 10.
15 is entered,
yeah.
And 10 is entered
into the second register, and then multiply is again selected using S1. As you can see, 50 would appear, and if we had a third 7-segment display connected, it would display 150. So just to again point out some the extra features of the board, we have set up the LEDs to display the first number being inputted and then the second number being inputted, just so that whenever the user can see the result of the calculation, they can also see what numbers they used in the first place.